Good morning to all. This is Suje, working as an assistant professor in AI&DS department. Good morning to all. This is Suje, working as an assistant professor from AI&DS department in SNS College of Engineering. Today we are going to see about thread lifecycle case study. The case study is online shopping application. So here the background is, imagine an online shopping application where users can browse products, add them to their cart and place order. Likewise, we are using Amazon, Flipkart, Myntra, etc. To provide a smooth user experience, the application uses threads to handle various tasks concurrently. As we are in Amazon, we'll be selecting the product and we'll be adding them in the cart, and after that we will place it in as an order. So this is the background process in online shopping application. The next is the thread lifecycle of the above case study. First is the creation. When a user initiates an action such as searching for a product, a new thread is created to handle this task. For each and every task and action, a new thread is created. For instance, when a user searches for smartphone, a search thread is spawned to fetch relevant products from the database. Next is running. That is, it enters the next state. The newly created thread enters the running state. It executes the search query, retrieves product information as we want the respective product. As we are searching for the respective product, it searches the related product and it will return back the information about the product and prepares the results for display. This thread is actively engaged in processing the user's request. After that, blocked. The state, while displaying search results, the application allows user to sort products by different criteria, as we are using filters for brand, for amount, that is for price, for discounts, etc. When a user selects a sorting option, a sorting thread is created. However, the sorting thread might need to wait for the search thread to finish fetching results before it can proceed. That is, if the next thread wants to execute, the previous thread should be completed. During this time, the sorting thread is in a block state. At that time, the current thread will be in a block state, waiting for the necessary resource to become available. That is, the previous state should complete and it should return a necessary information for the current state. That is for the current thread to get processed. Then last one is the termination. Once the search thread completes its task and displays the result, it enters the termination state. That is, when we want to search a new thing, we have to search first and the search will get processed and it will return the information next. And if the information gets completed, and for processing the next state, the current state thread will wait for the previous state result, and at last the termination. That is, the process gets terminated. That is, the thread process will get completed. The thread resource are released and it is no longer actively processing as we got the result for our search. Similarly, the sorting thread enters the termination state once it finishes sorting the product. Hence, object-oriented approach here is search thread, sort thread. Here, the search thread object encapsulates the logic for fetching and displaying search result. It may contain method to interact with the database, retrieve products, and update the user interface with the result, as I said before. Sort thread is nothing but a sort thread object encapsulates the logic for sorting products based on user preferences. It could have methods to perform sorting algorithms and update the display with the sorted products. Next is the benefits of OOPS and threat management. Using an OOPS approach to threat management offers several benefits. Modularity. Each threat's behavior is encapsulated within its respective object, promoting code modularity and reusability. Maintainability is threat-related logic is contained within dedicated objects, making it easier to understand and maintain the code base. Abstraction. The details of thread creation, execution, and synchronization are abstracted away from the main application logic, simplifying the development process. Separation of concerns. OOPS allows developers to separate different concerns such as searching, sorting, and UI updates into distinct objects and threads. This is the case study of our thread lifecycle about online shopping. How to place in online shopping and in an online shopping application, how the products are getting placed. Thank you. Let us see the next topic in next class.